In this lesson, we are looking at the properties of functions, and we're going to start with increasing, decreasing, and constant function. So if we look at increasing, we focus on from left to the right, and you can see the graph is going up. From left to the right, it's going down, that's decreasing. Constant, the values of y remain the same. And here let's look at some examples. If you look at this function, this is a quadratic function, and from negative infinity, as you come from the left to the right, from negative infinity to negative 1, and we focus on the domain, you can see the function is decreasing. It's going down. If you look at from negative 1 to infinity, you can see it is increasing. The values are increasing. So that's how we write it as an interval, and we focus on the domain. So we look at the next one. This one, it's only increasing. So I'm just going to write increasing. And it's increasing from what values? From negative 2 all the way to infinity. And that's how to do the increasing and decreasing. And in the same way you would do the constant functions. Now let's look at the next one. In this one, we are looking at odd and even functions. And I want you to pay attention to the formula here to use when we are checking whether it's even. There's a formula here. When we plug in negative x, it should remain the same. And we have an example here. Here we have the formula for checking when it is odd, and when you plug in negative x, the same as negative f of x. And here we are going to do examples. I'm going to show you, I'm just going to focus on the algebraic method and then go to the graphic method. So I'll start with the function given. So I'm given y is equals to, let me write it down, given y is equals to negative 5x plus 9x to power 7. So what do I do first? My first thing is to test whether it is even. And how do I do that? I'm going to do f of negative x. So when I do that, it means I'm plugging in x. And if I get the same value I have above here, then I know it's even. If not, then I'm going to test whether it is odd. So this becomes negative 5. And then I have negative x plus 9. And this is negative x to power 7. And this becomes 5x and minus 9x to power 7, because when I raise negative x to an odd power, it stays the same. So this is what I get, and I'm just going to highlight it because I'll need to compare it. And since I don't get the same value as I had at the beginning, so I'm going to write here not even. Just going to use not even, NE. Now I'm going to check whether it is odd. So how do I do that? If it is odd, if I plug in x, so if I plug in negative x, I should get, this is what I should get right here. So I'm going to, I should get negative f x. That's what I should get if it is odd. So I'm going to do negative. I take the original function. So this is f of x plus 9x to power 7. So this gives me, remember the original one had negative, so this becomes 5x minus 9x to power 7. Okay, so that is what negative f of x is equals to. So I'm going again to highlight this one, what I got here. And since what I see here looks like, from what I see here, this means f of negative x is equals to negative f of x. And according to the definition, it means the function is odd. It is odd. And how can I be able to see the same thing graphically? If it is odd, then it is going to be symmetric about the origin. And you can see here, this is symmetric about the origin. This is the point of symmetry. So it is confirmed this function is odd. Let's look at another example. And here we are given a function. We are going to check whether it's even, odd, or neither. So I'm going to start with f of x, which is equals to x to power 4 plus 5x to power 6. And I'm going to plug in negative x. And I just want to see what I'm going to get. So this is negative x to power 4 plus 5 negative x to power 6, negative x to power negative x to power 6. And when I do that, every time you raise a negative to an even power, it becomes positive. So this one is being raised to an even power also. So I get 5x to power 6. Now let me highlight what I have gotten here. And remember, this is the same as f of negative x. And what I see here, f of x is the same as f of negative x. So when I plug in negative x, the function remains the same. And that means it's even. It's even. How else can we verify that? If I look at the graph, I see it's symmetric about the y-axis. That's how we confirm it. If it's symmetric about the y-axis, then we know it is even. Let's go to another one here. And here we are given f of x is equals to 8 plus x to power 5. So again, you can see the procedure I'm using. I'm going to plug in negative x. And when I plug in negative x, what do I get? So I get 8, and this is negative x to power 5. So this becomes 8, negative x to power 5. And I'm going to highlight that. Let me save that. And I check it's not the same as original, so I'm going to write here f of x. F minus x is not the same as f of x. So what can I conclude from that? It's not even. So let me check whether it is odd. How do I check odd? To check whether it is odd, I'm going to do negative f of x and check whether it will be the same as what I just obtained up here. So this is going to be, you take the function 8 plus x to the power 5. So this becomes negative 8, negative x to the power 5. And is that the same as what I obtained? No. Let me make some conclusions here. F minus x is not the same as f of x. And then when I tried f of negative x, it's not the same as negative f of x. So what can I conclude? It's neither. So that's the answer. Now, let's move on. Let's look at boundedness of a function. If you look at this function, the minimum is negative 2. So this is called bounded below because this is the lowest it can go. This one is bounded above. So this one has a minimum. See, this one has a min and a max. So we say it's bounded above and below. And this one is bounded above. It has a max. Just note that this keep continuing. So that's how we are able to tell the boundedness of a function. The next thing here we are going to review is the maximum. So see, this is the absolute maximum, local minimum, and absolute minimum. And looking at these functions, so here we are going to do, let's do some examples. Let's do a quick review. So here, this is the absolute minimum, and this is the lowest possible value. The local minimum, you can see this is the local maximum. And this is the lowest in that neighborhood. I had the highest in the neighborhood. Local minimum is the lowest in the neighborhood, and absolute maximum is the highest value in the entire graph. And do some examples here. And give me 1 second. Just give me 1 second, and then I'm just going to be with you. It's going to be with you. Okay, now continuing, and some examples here. So here we have a function. We are told to find the local maximum. So where is the local maximum? So the local maximum is this point. Local maximum is going to be what value? 2, negative 2. And we are also told to look for the minima, local minimum. And what is the value? It's this value right here, 1, 2. So negative 2 and negative 5.